name is Ananga. I'm part of the data science discovery team, and in this video today we will be doing a question on data frame correlation. So let's go ahead and get started. So here we've provided a snippet of code that generates 10 random rows of data for 4 columns in Python. Right, this data is stored in a data frame. Given this, find the correlation between columns X and W, storing your answer in the variable R. So let's go ahead and go through this code, right? So we're importing our libraries here. We have defined our data, which is going to basically contain all of our data, right? And in lines 5 through 11, right, we're basically just having a for loop, right, where we're iterating 10 times, basically, because we're creating 10 random rows of data. And each time we're kind of defining these variables X, Y, Z, and W, which are random variables, and assigning them to basically a random number between 1 through 100. Right, and each time those are defined, we want to basically append those to a dictionary, right? Because these will be basically the row that is in each basically each row of our data frame, right? And this first value here represents the column. The second and the second value in this basically pair represents the value, which is the random number, right? So doing that for our X, Y, Z, and W variables, finally appending that row, that dictionary, basically to our data list, and then finally making that list into a data frame, right? So that's what our code is doing. If we want to go ahead and print out our data frame, right, so I'm going to kind of comment out these lines below and basically see what our data frame looks like. It's just going to be 10 random rows of data, right, with the columns X, Y, Z, and W. And our goal here is to find the correlation between X and W. So to do that in Python, right, they've already kind of done the hard part for us, which is defining the data frame. Now we just need to find the correlation. So to get the correlation coefficient, like matrix, basically the table that has the R values for all of the variables, that's going to be calculated using df.core, right? So here, this is basically our correlation coefficient matrix, right, which shows the correlation coefficient between all possible variables that are defined within our data, right? So it shows the R between X and Y, X and Z, X and W, and vice versa, right? And you might see here that this is basically like symmetric, right, because the correlation coefficient between X and Y is the same as a correlation coefficient between Y and X, right? So you can see here there's going to be some symmetries in this matrix, right? So we want to find the correlation between columns X and W, right? So to find that, it's basically this number right here, right, between X and W, or this number in this spot right here. It's the same thing, right? Because again, the correlation between X and W is the same thing as the correlation between W and X. So to get the actual correlation, right, and first of all, if I run this code as many times, right, it's always going to produce a different result because, again, this is random data, right? So to get the correlation coefficient between X and W, which is this number right here, right, I want to go ahead and use my .iloc function, right, because this is a data frame and I want to get the specific number. So again, the syntax for the iloc function is going to be basically the row comma the column index, right? So the row index here is going to be 3 because, again, we start the indices at 0, so it's 0, 1, 2, 3, and the column index is also 0. So we're going to, so the row index is 3, the column index is 0. So that's going to get the 0.40 value right here. And it's different each time, right? Because we're generating random numbers each time, right? So basically this can also be written, right, if you were to use the other correlation coefficient, right, you could also write 0,3. It's basically going to be the same thing, right, because as mentioned before, the correlation is the same no matter if you kind of switch the variables around. So the row and column doesn't matter here because we're dealing with that type of matrix, right? So this is basically going to be our answer, which is correct. So hopefully this video was helpful, and if you have any questions, right, leave them down in the comments below, and I'll see you next time. Bye.